Hey guys, welcome back to Zilliqa Zebra. Blockchain scalability is the holy grail and the bottleneck of the cryptocurrency world and mainly refers to transaction speed. At the moment, the transaction time of crypto doesn't compare to other payment methods. However, crypto communities are working within different theories on how to best overcome this hurdle. If you are curious about the promising developments in this space, such as Zilliqa's sharding, this video is for you. As always, don't forget to like and subscribe to Zilliqa Zebra for all things related to Zilliqa and its ecosystem. You may have seen the infographic above, which compares the transaction speeds of cryptocurrencies to Visa and PayPal. While Visa can process up to 24,000 transactions per second, Bitcoin can only process 7 TPS, and Ethereum can handle 20 TPS. Cryptocurrencies must catch up with Visa's capability to achieve mass adoption. But why is scalability so difficult on blockchain? Let's find out. How is transaction per second related to processing speed? What exactly does it mean when people ask if cryptocurrency is scalable? To answer those, we need first to understand the concept of throughput, finality, and confirmation time. Let's consider this simple analogy. You're waiting for a bus at a bus stop to go home. The bus arrives at a 10-minute interval, and it takes 60 minutes for the bus to arrive at your destination. The route is popular, and there's always a long queue of people waiting for the bus. 2 minutes have passed, and the bus has arrived, but there are too many people ahead of you in the queue, and the bus is filled. You now need to wait for another 10 minutes before you can begin your journey home. The journey can be summarized like this. Using the concepts demonstrated above in the context of throughput, finality, and confirmation, capacity of bus 7 persons per minute equals to throughput. Travel time from the bus stop to home, 60 minutes, is finality. Waiting to get on the bus, 10 minutes, average first block waiting time. Total travel time, 70 minutes, confirmation time. It should be noted that measuring throughput TPS is not enough. We must also consider confirmation time. Simply put, a protocol that can process up to 100,000 TPS is great. But if it has a 2-day confirmation time, that is not sufficient for daily life usage. When there is network congestion, throughput won't decrease since the bus can still carry 7 passengers per minute. But the confirmation time will deteriorate because of the longer average first block waiting time. Finality is a fixed waiting time. We need to wait for the 6 blocks confirmation to ensure that the block is not reversible. The average first block waiting time varies depending on the situation. The blockchain scalability trilemma is one of the greatest hurdles for cryptocurrencies. It states that you can only achieve 2 of either decentralization, scalability, or security simultaneously, but never all 3. Therefore, trade-offs are inevitable. The trilemma was originally coined by Vitalik Buterin, the founder of Ethereum, who invented the name regarding the scalability of the blockchain technology. However, do remember that the scalability trilemma is only an observation instead of a formal mathematical proof. Despite how difficult it is, an algorithm may exist that can solve the trilemma unless someone has proven that it is impossible. Decentralization refers to the degree of diversification in ownership, influence, and value on a blockchain. Cryptocurrencies are generally decentralized since no single party can govern the entire network. However, decentralization is a spectrum rather than a binary yes or no, as we see different levels of decentralization in various projects like Bitcoin, Ethereum, Ripple, EOS, etc. Security is the level of defensibility blockchain has against attacks from external sources and the resistance of the system to tampering. There are many attack vectors in a blockchain system, including double spending, SIBO, denial of service, and 51% attacks. In general, more freedom, that is, free entrance exit of the network, results in higher decentralization but lower security since it's harder to verify the identity of the new participants, where they can be owned by a single malicious entity or collude together to cause harm to the network. Scalability determines the network's capacity, including the number of nodes in the network, the number of transactions that the network can process, how fast the network can process, and so on. The term scalability is sometimes confusing because Bitcoin's blockchain is scalable upon new participants joining the network. The POW system will automatically adjust the difficulty, and the network can tolerate any numbers of nodes that exist in the network. The common saying that Bitcoin is not scalable is mainly focused on its throughput, that is, it can only handle 7 transactions per second, TPS, which is not enough for real-life usage when compared to Visa, which can reportedly reach 24,000 TPS. The finality speed is also another issue, as people won't wait 60 minutes to confirm that a purchase of a coffee is valid. Scaling blockchain is a complicated topic, and there are numerous efforts both from the crypto industry and academia trying to solve the scalability trilemma. In general, we believe there are three directions for the blockchain scalability. First layer on-chain, second layer off-chain, and other consensus. First layer solutions require changing the code base of the actual blockchain, hence on-chain. An on-chain scalability solution represents structural or fundamental change onto a blockchain. Here, we'll discuss two on-chain scaling solutions, Segwit and Sharding. Segwit is a protocol upgrade for Bitcoin and changes the way and the structure of how data is stored. The original intention of Segwit was to solve the transaction malleability problem. The digital signature that verifies the ownership and availability of the sender's funds takes up a lot of space in the transaction. Therefore, removing it will allow more transactions to be included in one block. Removing the signature data for each transaction releases more space and capacity for more transactions to be contained in Bitcoin's 1 megabyte storage blocks. Segwit has already been implemented in Litecoin. Though Segwit increases the throughput and helps Bitcoin to process more transactions, it's not a sustainable scaling solution for multiple reasons. First, Segwit is not a generic scaling solution. Second, it can be applied to the only Bitcoin-based blockchain. Third, Segwit enables Bitcoin to process more transactions, but does not reduce the confirmation time. Sharding is a form of database partitioning, also known as horizontal partitioning. The process involves breaking up a vast database into smaller, more manageable segments, with the idea of improving performance and reducing the query response time. Blockchain can be seen as a distributed database. If we apply sharding to the blockchain, then the blockchain network will be divided into different segments, and each segment is governed by certain nodes that has been allocated to them. By doing so, the throughput of the system can be greatly improved, since arbitrarily, many node clusters can be running in parallel to process the transactions. The main drawback of sharding a blockchain is its complexity and security. Hackers can easily overtake a single shard in a segmented blockchain due to the reduced hash power required to control individual segments. Once a segment is hacked, malicious transactions can be broadcasted to the leading network, disrupting the whole system. Another challenge with sharding is its complexity. Implementing sharding on existing blockchain networks is very difficult since it involves network splits and reassigning of state. Zilliqa is the first public blockchain platform to have implemented sharding. The Ethereum Foundation is also planning to use sharding in their next update, Ethereum 2.0. Other blockchain projects using sharding as a solution to scalability issues are Cardano, Harmony, and Quark Chain. Second layer scalability solutions or off-chain solutions add a second layer to the main blockchain network to facilitate faster transactions. The secondary protocols are built on top of the main blockchain, where transactions are offloaded from the main blockchain to save space and reduce network congestion. Sidechain is simply a separate blockchain linked to the main blockchain, main chain. The assets on the main chain and sidechains can be traded at predetermined rates using a two-way peg. Sidechains can be used to offload from the main chain by moving certain applications on the sidechain. Sidechain is one of the promising solutions to the scalability problem if inter-blockchain communication becomes more efficient. Multiple sidechains can be attached to the main chain, and each sidechain can have its own architecture. A network of sidechains with a main chain can be created where the main chain can act as a relay network, and the sidechains represent a blockchain network. Plasma and Parachain are popular scaling solutions using sidechain and relays. A payment channel is an off-chain network that runs parallel to the main blockchain. The idea is to establish a channel between two parties who want to make a transaction. All transactions that take place within the channel are off-chain, and global consensus is not required. As a result, these transactions execute quickly via a smart contract with much lower fees and at lightning speed. A typical payment channel has three phases. Phase 1. Establish a channel by signing and funding a channel. Phase 2. Peer-to-peer transactions on a payment channel. Phase 3. Close the channel and broadcast the final state to the main blockchain. There are several different designs of payment channels. The Lightning Network under Bitcoin and Raider Network under Ethereum are popular payment channel implementations. Hopefully, now you have a better overview of the major hurdles blockchain's transaction times are facing, and how blockchain scalability trilemma works in more detail. That's all I have for this episode of Zilliqa Zebra. Don't forget to subscribe to my channel for your regular dose of Zilliqa and cryptocurrency news. And check out my other videos which might be of interest to you. Goodbye.